Hey, welcome back to Future Tech Unlocked. Let's continue on unlocking the secrets of system design with today's topic that powers some of the largest tech giants. Think about platforms like Netflix, where millions of users interact simultaneously. Updates happen constantly, and the user experience remains seamless. Behind this efficiency lies a powerful architectural approach known as microservices. So, what exactly is microservices architecture? Picture this: instead of building one enormous application where everything is interconnected and dependent on each other, microservices architecture breaks it down into smaller, modular services. Each of these microservices is responsible for a specific task, whether it's handling user authentication, streaming videos, managing payments, or recommending content, and all of these services work independently. Microservices architecture is an approach where an application is broken down into small, independent services. Each service focuses on a specific function and works on its own. If one service needs to be updated or faces an issue, it doesn't affect the others. This makes the system more flexible and easier to manage, like fixing one part of a machine without stopping the whole thing. But why does this architecture matter so much? This architecture is a game changer for modern applications, delivering significant advantages in speed, scalability, and resilience. For example, let's say Netflix, where millions of people log in daily, each with personalized recommendations and seamless video streaming. Rather than managing everything in a single massive system, Netflix breaks down its functionalities into separate microservices. One service handles user profiles, another manages streaming, while a third powers content recommendations. This method allows Netflix to update or scale specific parts of the system without impacting the overall user experience. For instance, if they want to improve the recommendation engine, they can do so without disrupting video playback. It's a highly efficient, flexible, and reliable way to manage large-scale systems. Let's talk about how they compare to the traditional approach of building applications, the monolithic architecture. Understanding the differences between these two architectures is crucial for grasping why microservices have become the go-to solution for so many modern systems. So, what exactly is a monolithic architecture? In a monolithic setup, all the different functions or components of an application, like the user interface, data access, and business logic, are tightly integrated into a single, unified codebase. Think of it as a large block of code where all parts of the application rely on each other directly. When you want to add a feature or fix a bug, you often have to work within this unified structure, which can sometimes feel like trying to untangle a knot. Monolithic applications are designed to run as a single unit and are often deployed on one server or computing instance. On the other hand, a microservices architecture takes a different approach. Rather than building one massive application, microservices break down the application into smaller, self-contained services, each responsible for a specific function. These services are often deployed independently and can even be developed using different programming languages or frameworks. So, while monolithic applications are built as one solid block, microservices are like individual building blocks that work together but are not tightly bound to each other. Let's break down some key differences between these two architectures to understand their respective strengths and weaknesses. Scalability. Scaling monolithic applications is tough. Imagine an app where every function is tightly connected. If you want to handle more users or data, you typically have to scale the whole thing, which means adding resources to the entire system. This can be expensive and inefficient. With microservices, you only need to scale the parts that are getting the most traffic or demand. For example, if Netflix's recommendation feature needs more power, they can scale just that part instead of the entire system. It's a targeted approach that saves resources and keeps things efficient. Development flexibility. In monolithic architecture, developers usually stick to one tech stack for everything in the app, which can limit flexibility. Say you're building a monolithic e-commerce platform. If every part uses the same programming language, it can be challenging to innovate in areas that might benefit from different tools or languages. Microservices change this up by allowing each small service to have its own specialized tech stack. So the payment service might use one language, while the user authentication service uses another, whatever works best for each task. This gives developers freedom to choose the right tools for each job and lets teams work independently. Deployment and updates. With monolithic applications, making updates can be a hassle. If you update one part of the app, like the payment processor, you might have to redeploy the whole system, which increases the chance of bugs or downtime. In a microservices setup, each service can be updated on its own without touching the rest. So Netflix, for instance, can update its recommendation engine without affecting video streaming. This makes it easier to roll out changes faster and with less risk. Resilience and fault tolerance. One big challenge with monolithic apps is that if one part fails, it can bring down the whole system. For example, if the search feature on an e-commerce site goes down, it could impact other features as well. Microservices, however, make systems more resilient. Each microservice operates independently, so if one fails, the others continue to work, keeping the overall app running smoothly. This separation reduces the risk of a full outage. So in a nutshell, while monolithic architectures might be a good fit for simpler projects, microservices shine in dynamic, large-scale applications. The flexibility, scalability, and resilience they bring make them a game changer for companies that need to handle high user traffic and evolve quickly, just like Netflix or Amazon. That's why the choice between monolithic and microservices isn't just about code. It's about setting up a foundation for success in today's fast-paced tech landscape. So far, we've seen how microservices make applications more scalable and flexible, but they're not without some serious challenges. Let's dive into a few key disadvantages that come with this architecture. One of the biggest downsides of microservices is the increased complexity in managing and coordinating multiple services. In a monolithic application, everything is bundled together, so communication and data sharing are straightforward. But with microservices, you have independent services that need to talk to each other over a network, introducing added complexity. Imagine every time one service needs data from another, they need to coordinate over network calls instead of simple internal function calls. This requires a robust infrastructure to manage how data flows between services without delays or bottlenecks. Coming to another key downside of microservices, data management and consistency challenges. We all know how crucial data is, especially in applications where multiple services rely on it. In a monolithic setup, there's usually a single, centralized database, making it simpler to keep data consistent. However, in a microservices architecture, each service might have its own database designed specifically for its functions. While this approach gives services more independence, it creates new challenges in ensuring data consistency. For example, if a customer's information is updated, that change needs to reflect across all related services. Keeping each service up to date and resolving any conflicting information can quickly add a layer of operational complexity. Another major downside is the increased operational overhead. In a microservices setup, the sheer number of services that require deployment, monitoring, and maintenance grows substantially. Instead of managing just one application, as in a monolithic setup, you're now dealing with dozens or even hundreds of smaller services, each with its own deployment pipeline, monitoring needs, and security protocols. This means you need automated deployment processes, robust continuous integration practices, and specialized monitoring tools to track the health and performance of each service separately. As a result, operational overhead increases, often requiring skilled teams and advanced tools to manage everything effectively. Another challenge with microservices is networking and latency issues. In a monolithic app, functions can call each other directly within the same process, which keeps things fast. But in microservices, each interaction between services happens over the network, adding small delays or latency with every call. These milliseconds can add up, potentially impacting the overall user experience. Plus, network connections aren't always perfect. Interruptions or failures between services are possible. So microservices need a design that anticipates these disruptions to prevent system breakdowns. Another key consideration is cost and resource consumption. Each microservice often runs on its own virtual instance or container, meaning more servers and resources are required, which can drive up costs, especially if using cloud infrastructure. For large organizations, this extra expense is often worth the scalability and flexibility microservices bring. But for smaller teams or startups, it can quickly become resource intensive, particularly if they lack the budget or infrastructure to support this kind of setup efficiently. That's it for today, but don't worry, this is just the beginning of our journey into microservices. In our next video, we'll dive even deeper into this exciting topic. Thanks for tuning in. If you found this video helpful and insightful, please take a moment to like and share it with your friends and colleagues who might also benefit from learning about microservices. Your support enables us to create more valuable content and explore fascinating topics like this. We'd love to hear your thoughts or any questions you may have, so feel free to leave a comment below. And don't forget to subscribe to Future Tech Unlocked. By subscribing, you'll keep up with our latest videos, tutorials, and discussions that uncover the secrets of system design and much more. Your engagement is what drives us to continue delivering high-quality, informative content. Thank you for watching, and we'll see you in the next video.